Welcome to a tutorial video on C++. In this video, I'm going to talk about conditional statements. Conditional statements allow us to act on code and branch or do different things within it. In previous videos, we were simply defining things. We were stating ideas. We were stating values of variables, we were stating values of arrays, and we're stating or defining functions. With conditional statements, we can start to build on those concepts and branch in different ways. That is, we can compare values, compare variables, compare values within arrays, compare the results of functions, and then do different things and react in different ways. Allowing us to do that is conditional statements. So let's look at some examples here. We'll scroll down and I'm looking at lines 17 through 19 as the first example. 17 through 19 is an example of an if statement. Notice it looks very similar to what I reviewed in the previous video about functions. It has something within open and closing curly brackets, and has something within parentheses, and then it does something. In this case though, the if statement, notice it's highlighted right here, reacts to the expression or the statement that is within its open and closing parentheses. In this case, A is less than B. What this tests is the result of a Boolean value. A Boolean value in programming terminology is either true or it's false. It only has those two values. It's either true or it is false. So, in this case, we say, hey code, test to see if the value of A is less than the value of B. The value of A up here, defined on line 9, is 4, and it is an integer. The value of B on line 10 is 5. It is also an integer. 4 is less than 5. Therefore, the result of the expression A less than B is true. Remember, Boolean values are either true or it's false. In which case, this statement then becomes true. If it is true, it then does whatever is within the curly brackets. We can think of an if statement then allowing us to act on a true statement. If the expression is true, we do something. If it isn't, then we don't do it. In this case, we say, okay, A is less than B, so we print out A is less than B, because it is, it's true. So if statements allow us to react to expressions, and if they are true, if the expression is true, it allows us to do something, do whatever is within the opening and closing curly brackets. Now I skipped over part of a code, so let's rewind to look at that so we can examine some other ideas here. So I mentioned true or false are part of Boolean values. We can actually save Boolean values, true or false, as the data for variables, as the values for variables. Notice right here at lines 13, 14, and 15. These are 3 examples of using Boolean values. Notice it is a data type within C++, a bool, as a shorthand for Boolean. So, notice on line 3, we're storing the value true, and on lines 14 and 15, storing the values false and false. These follow the same rules of all the variables in C++. Letters, numbers, and the underscore, but no special characters or spaces. So we see here 3 Boolean values, lines 13, 14, and 15. Okay, so now we're ready to scroll down a bit. I'm going to skip down to lines 27 through 29. Remember when I had explained an if statement within C++? I said if it is true, it does something. If the expression is the Boolean value true, it does something. Now, I just explained that we can store Boolean values as variables using the bool data type, in which case, this right here, line 27, is true, because the result of the expression, first value, is the value of the variable first bool. First bool is defined on line 13 as true. Therefore, this is now true, and first bool is true will be printed line 28. So, using Boolean values as variables allows us to also use them as expressions within if statements. So we can use the result of the expression A minus B, but we can also use the value of variables as Boolean values within the if statement as well. So these are 2 different approaches to that. we can use the result of some expression, or we can use a Boolean value which will either be true or it's false. And remember, an if statement reacts if it is true. If the result of the expression or the values contained within it are true, therefore it does something. In the case of line 18, it would print A is less than B, and on line 28, it would print first bool is true. So we've established if statements that react to expressions and values. If they're true, it does whatever is inside the open and closing curly brackets. Let's get a little more complicated here. So we can react if something is true and then do some code. We can also react if the combination of expressions or values is not true as well. And the way this expression goes is if this, else that, to help you memorize it. So if this, else that. It's a shorthand mnemonic to help you memorize this. If this, else that. Let's look at an example of that. We see this right here on lines 21 through 25. If the result C is less than A, and let's make sure we know what those are. C is 6, A is 4, 6 is not less than 4. It would print this, but this expression is not true. Else it will print this other thing. The else keyword captures the result of a negation of if. It's a complicated way of saying that an if statement checks to see if something is true and then reacts. If it is true, it will run its code. So if this, else that. If the if statement is not true, that is, the result is false, the else statement allows us to do something else. Think of this as checking something like, hey, is this drawer open? It's not? Okay, well, then I won't reach into it. Something like that. So if this, else that. In this case, the else keyword also has opening and closing brackets, curly brackets, and defines some other code. In this case, C is not less than A, which is true. So this was false, so then it jumped over to the else keyword. So we can combine those two ideas. If it's true, it does whatever is within the curly brackets for the if, else it does whatever is within the curly brackets for the else. If this, else that. And remember, we're acting on true, things that result of true, either Boolean values that are true set to the value true, or the result of some expression, testing using less than, greater than, less than or equal to, or greater than or equal to, which is covered more in the blog post that's linked in the video description of this video. So let's move on a little bit. We've got Boolean values, we've got expressions, and we've got if and else. So we are testing to see if this expression or this value is true. If it is, we do something, else we do something else. We can complicate by looking at negations. Negation uses the exclamation point. It's one of the rare things that acts on a single value. Previously, when we looked at variables, we saw when we use the addition symbol or the subtraction symbol, we can add or subtract two different values. In the case of negation, it works on a single value, and it only works on Boolean values or Boolean expressions. That is, if the expression of something would have been true, it is now false. If it would have been false, it is now true. You can think of it as flipping the values. It negates it. True becomes false, false becomes true. In this case, second bool, which is defined up here on line 14 as false. The negation of false, though, is true. So, using the negation operation on the value of second bool, which would have been false, makes it true, therefore makes the whole statement true. And we see right here, second bool is not false. Not false is therefore true. So we can negate that and switch it. This is especially helpful with some functions that return false. For example, if we're testing something is not a number, the result would be something we want to negate if we care about something is a number. So this is something to think about, is we can negate expressions that result in Boolean values and negate those Boolean values. It's a weird little trick that allows us to think about ways to switch Boolean values back and forth. Not false is true, not true is false, as well as act on expressions. So if we care about something is less than something, we can then react on that, or we can negate that Boolean response to either true or false. A little confusing, but it's useful to know. There's two other things we should be aware of, is the or and the and. Right here on line 35 through 37 allows us to combine things. In previous examples within this video, we were looking at either single expressions, A less than B, or single values. We can combine those using the or. This is two bars next to each other. This reacts to Boolean logic, which is a little bit complicated, but not too hard to get your head around. Boolean logic follows Boolean values. Boolean values are either true or they're false. That's it. So, Boolean logic allows us to combine those things to build complex expressions. In this case, we're looking at the value of the variable first bool, which we know to be true, and the value of the variable third bool, which, to just double check, we know to be false. The or statement says if either of these things are true, then the statement is true. It is or. This or that. If this is true or this other thing is true, the whole thing is true. So this allows us to say that one of these things is true, which is the result it will print out on line 36. We can also use the negation within the compound expression. Again, just building more complexity here. So when we talked about line 31, we negated the value of second bool. The value of the variable second bool was false. When false is negated, it becomes true. Again, Boolean values only have true or false values, so we can switch between them very easily. So we saw it was not false. Not false is true. We also see that compound idea right here as a conclusion on line 39. We see first bool is true, or the negation of third bool. The value of the variable third bool is false, but its negation is true. So we have true or true. Both of them are true, which is what we want to see here. Both of them are true. And in fact, I can change this to the and. And so now we have the and symbol. So when we looked at line 35, we saw the or, this or that. The and, two ampersands, similar to two bars, checks if both of these are true. First bool is true, and the negation of third bool is also true. This is true, and this is true. So we can use or to test either one, and to test both, which could be useful in the case if we need to know if multiple things are true at the same time. That is, if this variable is less than this value, and if this other variable is less than this value. So we've built a whole bunch of ideas here using conditional statements. Let's scroll up the top and review. We established some initial values. Right here, lines 9 through 11, A, B, and C, and lines 13 through 15, Boolean data types, first bool, second bool, and third bool, in order true, false, and false. I discussed how Boolean values either have true or false. They can be only those two values. Then we said if we looked at if statements, they react to the result of some expression or the result of a value of a variable. In this first example, A is less than B, and we test that. Is A less than B? Well, 4 is less than 6, so this is true then. If the result is true, we run the code as within the opening curly brackets associated with that statement. That is, it will run line 18. We then looked at some other examples using if and else, and I gave this mnemonic if this, else that. So if this is true, then we do this, else if this is not true, then we do that. We saw that right here. C is not less than A, and so line 22 will not be run. However, line 24 will, because the else keyword is used here. So if this, else that. We also talked about using the value of the variables using the data type of bool. That is, right here, this will be true because the value of the variable first bool is true. We also talked about negation. Not false is true and not true is false. We talked about combining them using or we're looking at two different expressions or two different values. Either this is true or this is true. So one of them has to be true for the statement to be true. And we looked at the AND statement down here, or the AND operation. We need both of these to be true. So first bool is true, and the negation of third bool, which was false but negated becomes true, means both of these are true. Let's run this. Those are all the reactions we expected. A is less than B, we saw in line 18. C is not less than A, we saw line 24. First bool is true, it is. Second bool is not false and therefore true, it was negated. One of them is true on line 36. First bool is true or third bool is true. And on line 39, both of them are true. The negation of third bool from false to true makes it true, and first bool with its value of true is also true. Thanks for watching.